Welcome to our physics laboratory. So today we are going to discuss about the experiment determination of wavelength of a semiconductor laser. For this the apparatus required are laser source, grating and screen. So what is the formula used here to find the wavelength means lambda is equal to sin theta by n. Here theta is the angle of diffraction for laser in degrees and n is the number of lines per unit length of grating in lines per meter. So the n value is a constant for a grating, that is 15,000 divided by 2.54 into 10 power minus 2, which gives 5,90,551 lines per meter. So this is the semiconductor laser and this is grating, so in which there are 15,000 lines are drawn per inch. So by using this we can find the capital N value, and this is the screen. When the source is switched on, the light source emits the laser light and it will be allowed to pass through the grating. When it passes through the grating, the light gets diffracted and it will be appeared on the screen. So these are the diffracted images, that is laser spots. Okay. So this is the tabular column to find the sin theta. By using this sin theta value we can find the wavelength of the laser. So for this we need the laser spot distances x1 and x2. So first one, distance between the grating and the screen, d. Second one, x1, it is the distance between the center point and the left side point, and x2 is the distance between center point and the right side point. And the next one is x, this is the average of x1 and x2. By using this d value and x value we can find the sin theta by using the formula x divided by square root of x square plus d square. So initially we can take the distance as 13, that is the distance between the grating and screen. The position of the grating, and this is a screen. So the reading starts from 0 to 1, 2, 3 etc. So here I am placing the grating at the distance of 13. So the distance between the grating and the screen is 13 centimeter. Okay, so when laser light passes through the grating, it gets diffracted and the diffracted images are appeared on the screen. So this was the direct light ray laser spot, and these are the diffracted images. So first x1 means the distance between this center spot and left side point, and x2 means the distance between center spot and the right side spot. So first one, x1, so we can measure the distance by using normal scale. So first one, so the distance between center point and left side point, so the distance is 5.2 centimeter, and the next one, the distance between right side point and the center point, and this is the 5.3. so we can write here as 5.3, and this is the average of x1 and x2, 5.25, and by using this x value and d value we can find the sin theta value. So this is the formula. By substituting the x value and d value we can find sin theta. So sin theta value is 0.3744. By simplifying this we will get this value, and by substituting the sin theta value in the formula of wavelength we can find the wavelength of the laser. So lambda is equal to sin theta by n. Sin theta value is 0.3744 and divided by n value is 5,90,551. By simplifying this we will get the value of 6.3409 into 10 power minus 7 meter. So generally we are expressing the wavelength value in angstrom. So first we have to convert this into 10 power minus 10 meter, then it will be converted into angstrom. So in meter the wavelength is 6340.9 into 10 power minus 10 meter. So 10 power minus 10 meter is 1 angstrom. So wavelength of the given laser is lambda is equal to 6340.9 angstrom. So we can write this value in the result part.